physics, Newton's laws, P22A, so this is exactly the first one. Recall examples of ways in which objects interact. So let's look at examples of ways in which objects interact. Let's get the first situation will be when the objects are in contact with each other. So by contact with each other, we have a crate that's sitting on a horizontal surface, and if we zoom out to that specific place over there, on the bottom we see that the brown part is the crate, the blue part is the surface, but they're not perfectly smooth. So that means when they will be in contact one with another, it's not going to be super easy to move them, because there is. Now, if you're pushing the crate, you see we're trying to push the crate to the right, so that's the direction of motion or attempted motion, and then there will be a force of friction going to the left that will maybe prevent this crate from moving. Now, we don't know if the crate is moving or not. If we look at the size of the arrows, we see the size of the size of the arrow that's pushing the crate to the right. It's much bigger than the size of the arrow that's trying to stop the crate or the force of friction. That means probably this crate will move. Probably this crate will move to the right. So two of the contact forces that we can analyze here. Number one would be the pushing force, the one that's pushing the crate to the right, and then next one would be the friction force, the one that's kind of like, it's not pushing the crate to the left, but it's trying to stop the crate from moving. That's why it's going to be oriented to the left. This the same diagram in a more simplified way. We see if the motion we try to push the crate to the right. Now here we have two options. The crate is moving to the right or is trying to move to the right. There will always be the friction oriented to the left, because friction is always oriented against motion. So if we had tried, let's say, to move this box to the left, the friction would have been oriented to the right. So friction is always oriented against motion. So that means, let's go back a little bit. Contact forces, a pushing force, and friction force. These are contact. They need contact to happen. Now, a child is going on a sled. It's going down the ramp. Now here, what forces do we have? We represent them with arrows. So we have a force that's pushing the child to the right, which is going to be the applied force, and then we have a force that's trying to prevent this motion to happen, is going against this applied force, which is the friction force. Now in this situation, so contact forces, applied force, and friction force. In this situation, we see the size of the arrows are the same, so that means this will be balanced forces. Another contact force here is the reaction force that's coming from the surface the object is sitting on or is moving on. And this reaction force that's coming from the surface is oriented upwards, because the surface is where the sled is moving on, so it's going to be oriented upwards, and this is called the force of reaction, which is called the normal force. So we have one contact force, the push force, another contact force, the friction force, the third contact force, the normal force. But the fourth force that's arising in here doesn't need contact to interact, and this is the force of gravity. Now, gravity attracts objects that are sitting on the ground, but it also attracts objects that are flying around the ground, or that are jumping in the ground, that are flying like a plane, or let's say something that's flying on the ground like a tennis ball for just a short amount of time. So the force of gravity is a force that doesn't need contact to interact. The direction of the force of gravity is always downwards, because it's always oriented towards the center of the earth. That's where we consider that the strength of the earth, the pull of the Earth is coming from. It's coming from the center of the Earth. That's why the arrow on this sled for the force of gravity is going to be moving downwards. Here, if we see these different people standing around the Earth, now the arrows will always be pushing towards the center of the Earth. From each one of this person, the arrow is going to be pushing towards the center of the Earth. So the direction of the arrow is always going to be downwards. The direction of the force of gravity is always downwards. It's always towards the center of the Earth. Okay, so this gravity is already a non-contact force. Now, another non-contact force is the magnetic force. For example, the force that arises around magnets. Here we see this can be attractive. Remember from lower classes, like north and south pole of a magnet will attract each other. There is the electric field. That's the field of force that acts on objects being around those magnets. And for example, if we have south and south, they will be repelling each other. Now, as you can see here, this magnetic force, which is a non-contact force, it doesn't need contact to happen. Here is just attracting some iron filling that was just attracted by this, just by being around this magnet, not necessarily in direct contact with this magnet. And another non-contact force is the electrostatic force. That means is the electrostatic force, the one that's coming from electric charges. Like for example, you rub a comb or on your hair, for example, on your clothes, and then this comb will attract different pieces of paper, even if the comb is not in direct contact with these papers. They will attract it because around the comb there'd be an electrostatic field of force. The same thing here. For example, when the lightning happens, well, electric charge is coming from the clouds to the ground through a long distance, probably a few kilometers, even though there is no direct contact between the cloud and the Earth, just because, well, in this situation there are some conditions that allow for this lightning to happen. But this is due also to the electrostatic force, which is a non-contact force.